Welcome back, everyone. Ready to dive in deep today?
Always. What wonders of science and medicine are we tackling this time?
Buckle up, because today we're going on a wild ride through the world of neurology.
Oh, the brain. Full of mysteries.
Right. We're going to be talking about how the brain works, those baffling neurological disorders we always hear about,
Hmm.
and get this, even how some infections that seem totally normal might actually be playing a role in all this.
Fascinating. What kind of infections are we talking about here? Spell the T.
Well, you'll have to wait and see, but trust me, it's going to be eye-opening. You ready to unravel some of these neurological mysteries?
Let's do it. I'm all ears.
All right, let's start with something we hear about all the time. Dementia. I feel like everyone knows someone who's been touched by dementia in some way. But the fact that cases are expected to more than double by 2050, that's pretty alarming. What exactly is dementia, though? Is it just memory problems, or is there more to it?
You've hit on a really important point. Dementia isn't just one thing, you know? It's not as simple as just forgetting where you put your keys. Dementia is actually an umbrella term.
An umbrella term. What do you mean by that?
Well, it's a term that covers a whole bunch of different symptoms, all related to thinking, memory, and even your ability to, hold a conversation or do the things you used to do easily. And these symptoms are serious. We're talking about stuff that really interferes with your daily life. The real culprit behind all of this is damage to brain cells.
Damage to brain cells.
Yeah.
So it's like the brain's not working the way it should.
Exactly. And the thing is, a whole bunch of different diseases can cause this kind of damage. So dementia is less like a single diagnosis and more like saying, oh, you've got a heart problem.
Right. Not very helpful until you know exactly which heart problem is going on.
Precisely. So with dementia, we need to figure out what's causing that brain cell damage to really understand what we're dealing with.
Okay, that makes a lot more sense. So with all these different potential causes, where do we even begin? What are some of those common types of dementia we should know about?
Well, one of the biggest ones, and the one that probably comes to mind for a lot of people, is Alzheimer's disease.
Alzheimer's, yeah, it feels like it's everywhere, sadly.
It really is sadly very common. And what's interesting about Alzheimer's is the way it affects the brain. You've probably heard of plaques and tangles, right? They're kind of the hallmarks of Alzheimer's disease.
Plaques and tangles. I've heard those terms before. What are they exactly?
Well, imagine your brain is like a giant network of roads and highways, all those pathways allowing information to travel throughout your brain. Those plaques and tangles basically mess up those roads, making it really hard for signals to get through.
So the brain's communication system gets all jammed up.
Exactly. You see, those plaques, they're made up of this protein called beta amyloid, and they kind of clump together between brain cells, like gumming up the works.
Ah, so that's the plaque. And what about those tangles?
The tangles are made of a different protein called tau, and they mess things up inside the brain cells. You see, brain cells have these internal pathways that act like a transport system. But when these tau proteins go haywire, they form tangles that block up those pathways, and the cell can't function properly. It's like the cell's internal transportation system completely breaks down.
Wow, so it's like a double whammy. The plaques are messing up communication between cells, and the tangles are wreaking havoc within the cells themselves.
Exactly. It's like the brain's infrastructure is slowly falling apart. And all that damage, it eventually leads to the cognitive decline that we see in Alzheimer's patients.
That's heartbreaking. It makes you appreciate just how delicate that balance is in our brains. Is there any hope on the horizon for preventing or treating this? It feels like we hear about potential breakthroughs, but nothing really pans out.
There is actually some really promising news on that front. Researchers are working hard on developing vaccines for Alzheimer's.
Wait a minute, vaccines, like the kind we get for the flu, for Alzheimer's.
Yeah, it sounds kind of crazy, right? But the idea is that these vaccines could help the body get rid of those harmful amyloid plaques before they have a chance to do too much damage. It's still early days, but the research is looking really promising.
Wow, that's incredible. If these trials are successful, we could be talking of a real game changer for millions of people. It's amazing to think about what medical research can accomplish. But we were talking about different types of dementia. What about Lewy body dementia? I've heard that name before, but I don't really know much about it. What is it exactly?
Lewy body dementia. That one's really interesting because it's like getting hit with a double whammy. It affects both your movement and your thinking.
So it's a combination of issues then.
It's like a combination of Alzheimer's and Parkinson's disease, both leaving their mark on different parts of the brain.
Wow, that sounds incredibly challenging, facing both sets of issues at once.
It absolutely is. It's a lot to deal with, both for the person experiencing it and their loved ones.
I can only imagine. Is there a way to know more specifically what that experience is like for someone with Lewy body dementia?
To really grasp the human impact of Lewy body dementia, it's helpful to hear from those who've experienced it firsthand. Robin Williams, the incredibly talented actor and comedian, he struggled with Lewy body dementia before his passing.
Oh, wow. I didn't know that.
Yeah, and his wife, Susan Schneider-Williams, she's been incredibly vocal about his experience trying to raise awareness about this often misunderstood disease. She said something that really stuck with me. She said, Robin was losing his mind, and he was aware of it. He hated that he could not find the words he wanted in conversations.
Oh, wow. That's heartbreaking. It's easy to get lost in the medical terminology, but those words are a stark reminder that behind every diagnosis, there's a real person facing unimaginable challenges. It's so important to remember that human side of things. It's easy to get caught up in the science, but these diseases have a real impact on people's lives. And speaking of impact, you mentioned Parkinson's disease earlier. How does that tie into Lewy body dementia again?
Well, they both involve these protein clumps. We were talking about Lewy bodies, but it's like,
Yeah.
imagine two different gangs causing trouble in different parts of town.
Okay, now you've got my attention. Tell me more about these gangs.
So in Parkinson's disease, the main troublemaker is this protein called alpha-synuclein, and it forms these Lewy bodies mainly in an area of the brain called the substantia nigra. This little area is like Grand Central Station for movement control.
So, same culprits, different targets. What happens in the brain with Parkinson's then?
This is where things get really interesting. Both Parkinson's and another condition, Huntington's disease, they both involve this area deep within the brain called the basal ganglia. Think of it like your brain's movement choreographer, making sure everything runs smoothly.
Okay, I'm following so far. The basal ganglia is like the control center for movement.
Right. But here's the thing. Parkinson's and Huntington's mess with the basal ganglia in totally opposite ways.
Oh, wow. Okay, now I'm really curious. How can two diseases affect the same area but in opposite ways? That's wild.
So imagine your brain has these two pathways for movement, a go pathway and a stop pathway.
Like a gas pedal and a brake pedal?
Exactly, you're driving. And these pathways, they need to work in sync to make sure your movements are nice and smooth. Now, with Parkinson's disease, the stop pathway gets a little too powerful, too overactive.
Too much brake, not enough gas.
You got it. And it all comes down to a lack of dopamine in the brain.
Dopamine, that's a neurotransmitter, right?
You know it. One of those chemical messengers we talked about earlier, dopamine is like the go signal's best friend. So less dopamine means the go signal gets weaker and the stop signal takes over. It's like your brain is constantly hitting the brakes.
So it's like being stuck in traffic, but in your brain. No wonder people with Parkinson's have trouble initiating movement.
That's a great way to think about it. Now, for the flip side, Huntington's disease. Remember we were talking about that earlier?
Yeah, there's one Woody Guthrie, the folk singer, had, right?
That's right. With Huntington's, you have this genetic mutation that actually throws a wrench into the stop pathway.
Wait, so it's like cutting the brake lines?
Essentially, and what happens when the brakes fail?
Things get a little out of control.
Exactly. You get these excessive, often jerky, involuntary movements. It's like the go signal is stuck on and there's no way to stop it.
Wow. So both diseases affect the same area of the brain, the basal ganglia, but with completely opposite outcomes. One's like hitting the brakes too hard and the other's like slamming on the gas with no brakes.
It really highlights just how delicate that balance is within our brains. And unfortunately, both Parkinson's and Huntington's, they're progressive, debilitating diseases. They really show how impactful these neurological disorders can be on a person's life.
It's scary how much these diseases can impact someone's life. And it's a good point about how genes can play such a big role. Like with Parkinson's, there's a higher chance if it runs in your family. But Huntington's is directly caused by a single gene mutation.
It shows this incredible interplay of nature and nurture and all of these neurological disorders. And speaking of intricate systems, let's shift gears a bit and talk about multiple sclerosis, or MS as it's commonly known.
Look, MS, I know it has something to do with the immune system attacking the nervous system, right?
You're on the right track. Think of your nerves like those electrical cores we talked about earlier, with that protective coating called myelin.
Right, like insulation to keep the signal strong.
Exactly. But in MS, your immune system gets confused and starts mistaking myelin for an enemy, attacking it.
So it's like stripping the insulation off those electrical cords. What happens then? Does the signal just stop?
It's more like the signal gets all messed up. It can't travel properly without that insulation. And this can lead to a whole bunch of different symptoms, depending on where the damage is happening. Muscle weakness, fatigue, problems with vision. even things like balance and coordination.
So it can affect everything.
It's a real mixed bag, and it's different for everyone, which makes it even more challenging to diagnose and treat.
Wow, it sounds like MS is a real chameleon.
It really is. Some people experience these periods of relapse and remission where symptoms flare up and then die down, while others face a more progressive form of the disease where things just gradually get worse over time.
That must be so difficult to deal with, not knowing what to expect.
Absolutely. It can be really tough. That's why it's so important to work closely with healthcare providers to find the right treatments and manage the symptoms as best you can. There are a lot of options out there, thankfully.
That's good to hear. It's incredible how complex these systems are. And when we're talking about conditions that directly impact those vital pathways, another one that always seemed particularly scary is amyotrophic lateral sclerosis, or ALS.
It is a tough one. ALS is a devastating disease. It gradually robs people of their ability to control their muscles.
It's the one often called Lou Gehrig's disease, right? After the famous baseball player. It's heartbreaking.
It is. With ALS, those nerve cells, the ones responsible for telling your muscles to move, they get damaged. And they can't repair themselves, unfortunately.
So once those cells are damaged, that's it. There's no coming back from that. Are there any effective treatments available at this point?
We haven't found a cure for ALS just yet, but there are treatments out there that can help manage the symptoms and potentially slow down the progression. Riluzole is one medication that's shown some promise in clinical trials. It's not a cure, but it can make a difference for some people.
Well, hopefully with more research we can find better treatments and eventually a cure.
I hope so too. There are a lot of brilliant minds working on it, so I'm hopeful for the future.
It's a good reminder that while we've made some incredible strides in understanding these conditions, there's still so much we don't know. But speaking of conditions that affect the muscles, what about myasthenia gravis? That one always seemed kind of mysterious to me.
Oh, it's a fascinating one. Myasthenia gravis is all about communication, but this time it's a breakdown at the meeting point between nerves and muscles, the neuromuscular junction. So you've got your nerves sending a signal, right?
Okay, got it. A message is on its way.
Exactly.
Yeah.
And that message, it's carried by this chemical messenger called acetylcholine. It's acetylcholine's job to tell the muscle to contract.
Okay, so far so good. The message is sent. What could go wrong?
Well, in myasthenia gravis, your own body starts producing antibodies. And these antibodies, they're like little troublemakers that block or even destroy the receptors for acetylcholine.
So it's like sending a text message that never gets delivered.
That's a perfect analogy. The message is being sent, but no one's picking up the phone. And because the muscle isn't getting the memo, it can't contract properly. That's why muscle weakness and fatigue are the hallmarks of this condition.
So it's not that the muscles themselves are weak, it's that communication line that's disrupted. It's fascinating how much of this comes down to these tiny little messengers and signals. You know, it's amazing how much we're talking about communication, even when it comes to our muscles. Look, our bodies have these intricate messaging systems, and when those signals get crossed, things can really go haywire.
It's a delicate balance, that's for sure. And it makes you realize just how incredible our brains and bodies are for keeping everything running smoothly most of the time.
Right. It makes you appreciate those moments when everything's working as it should. But thinking about those crossed signals makes me think about mental health. Our brains play a huge role in conditions like anxiety and depression too, don't they?
Absolutely. Mental health conditions are every bit as neurological as the ones we've been discussing, even if they're often categorized differently.
Right, because it's not like there's always a visible culprit, like a tumor or a damaged nerve, but the impact on people's lives is just as real, if not more so.
Exactly. And it's a good reminder that even something like anxiety, we all experience it to some degree, right? It's a normal human emotion. But it's when that anxiety becomes excessive, persistent, when it starts to take over your day-to-day life, that's when it crosses the line into an anxiety disorder.
So it's about that difference between everyday worries and the kind of anxiety that just doesn't quit.
Precisely. Think about it this way. It's completely normal to feel anxious before giving a big presentation or going for a job interview.
Oh, tell me about it. I'd be lying if I said I didn't get a little nervous before these deep dives.
Well, see, that's a perfect example. That's your body's natural fight or flight response kicking in. It's trying to protect you.
Protect me from what? Sounding silly on a podcast.
Maybe. But in all seriousness, that response is there for a reason. It's what helped our ancestors survive in dangerous situations. But when that response gets triggered in situations that aren't actually dangerous or when it just won't turn off, that's when it becomes a problem.
So how do you tell the difference? When does that normal anxiety become something more serious?
Well, if you're constantly worrying about things you can't control, if it's affecting your sleep, your work, your relationships, that's when it might be time to reach out to a professional.
It's like anything else, right?
Yeah.
When it starts interfering with your life, it's time to get it checked out. And even within anxiety disorders, there are so many different types, each with its own quirks. Like panic attacks, those sound absolutely terrifying.
They can be incredibly intense, that's for sure.
Yeah.
Imagine this. You're going about your day, and suddenly, this wave of overwhelming fear just washes over you, seemingly out of nowhere.
Oh, wow. That sounds awful.
Your heart starts racing, you might feel dizzy, short of breath. Some people even feel like they're having a heart attack.
I can see why.
And that feeling of impending doom, like something terrible is about to happen, it can be really scary. And the thing is, these panic attacks, they can happen in a whole bunch of different situations.
So you're saying they're not necessarily their own separate thing.
Exactly. Panic attacks can be a symptom of other anxiety disorders too. Panic disorder, of course, but also generalized anxiety disorder, PTSD, even phobias.
Okay, so let's talk about phobias for a second.
Yeah.
Because those are another one where the fear response seems to go into overdrive. Like, we've all been there with a spider or two, but phobias are next level.
You're right. With phobias, the fear is way out of proportion to the actual danger posed by the object or situation. And it's not always those common ones either. Like, I don't know if you've heard of this one, arachibutyrophobia.
Say that again? What is that?
Arachibutyrophobia. It's the fear of peanut butter sticking to the roof of your mouth.
Seriously, people are afraid of that.
They are. And I know some of them sound funny, but the fear is very real for people who experience it. It just goes to show how complex these anxiety responses can be.
It really does. And it's not a joke. It's important to remember that people with phobias usually know on some level that their fear is excessive.
Right. They're not delusional. They just feel powerless to control it.
That must be so frustrating.
Yeah.
And it can be so debilitating, too. Like agoraphobia, that one's not just about being afraid of open spaces, right?
You're spot on. It's more about that fear of being trapped in a situation where escape might be difficult or help wouldn't be available. Like imagine being stuck in a traffic jam and having a panic attack.
Oh, no. That sounds horrible.
It's like that feeling, but it can be triggered by all sorts of situations. For some folks, even the thought of leaving their homes can be terrifying.
Wow. That's really isolating. And then there's social phobia, which I imagine is a lot more than just being shy or introverted.
Exactly. Social phobia is this intense fear of social situations, like meeting new people or speaking up in public. It's often driven by this dread of being judged or humiliated by others.
Oh, yeah. I think we've all felt that to some degree.
Sure, but for people with social phobia, it's so intense that it can have a huge impact on their work, their relationships, really, all aspects of their lives.
It's easy to see how all these anxieties can make it hard to just, well, live your life. And it makes me think about mood disorders, too, because while anxiety seems to be about this excessive fear, depression seems to be more about this overwhelming sadness, right?
Yeah, that's a common way to think about it. But it's important to remember that depression is so much more than just feeling sad. It's not just a bad day or a bad week. It's a serious medical condition that affects your thoughts, your feelings, your behavior, even your physical health. It impacts every aspect of your being.
So it's all-encompassing, like it really seeps into everything.
Exactly. And it can show up in different ways for different people. For example, there's major depressive disorder. That's often what we think of as classic depression. You know, that period of 2 weeks or more where you're experiencing those really intense feelings of sadness, hopelessness, loss of interest in things you used to enjoy. But there's also postpartum depression, seasonal affective disorder, persistent depressive disorder, which is sometimes called dysthymia. There's so many variations.
Wow, so many different ways it can manifest. It's definitely more complex than just feeling down in the dumps. And speaking of complex, I've heard that this idea of depression being solely caused by a chemical imbalance in the brain, like just low serotonin, is kind of an oversimplification.
You're right. It's not quite as simple as that. While those neurotransmitters we've talked about, like serotonin, dopamine, norepinephrine, they definitely play a role in mood regulation, but it's far more complex than just a simple chemical imbalance, if it were only that simple.
Right. Like if it were as simple as just needing to increase one chemical, we'd have this whole depression thing figured out by now.
Yeah.
So what else is going on? If it's not just a chemical imbalance, what's causing depression?
It seems to be a combination of factors, like this perfect storm. You've got your genetic predisposition, your life experiences, environmental factors, and yes, brain chemistry is in there too, but it's not as straightforward as we used to think.
So it's like this complex web of influences that all contribute.
Exactly. And that's why treatment for depression often involves multiple approaches, like therapy, medication, lifestyle changes. It's about addressing all those different factors.
It's about finding what works for each individual because, like you said, everyone experiences these things differently. And speaking of conditions that involve these shifts in mood, bipolar disorder is another one that often comes up. That one's characterized by these extreme highs and lows, right?
You've got it. Bipolar disorder is all about those intense mood swings. You go from periods of like almost boundless energy and activity, we call that mania, to those deep, dark lows of depression.
It's like being on a roller coaster that you can't get off of.
That's a great way to put it. And it can be incredibly difficult to manage those extreme highs and lows.
Yeah, aren't there different types of bipolar disorder too? I
Yeah.
vaguely recall something about bipolar I and bipolar II.
You've got a good memory. You're right, there are different types. Bipolar I involves experiencing at least one full-blown manic episode, and these episodes can be so intense that they might even require hospitalization.
Wow, that's serious.
It can be very serious. Bipolar II, on the other hand, involves a less extreme form of mania called hypomania, along with those periods of major depression.
So it's about the intensity and duration of those manic episodes. What differentiates the two? It makes me think about celebrities like, Kanye West and Mariah Carey, who've been very open about their experiences with bipolar disorder.
And their openness is incredibly important. It helps to reduce the stigma surrounding these conditions and shows that mental illness, it doesn't discriminate.
Exactly. Mental health struggles can affect anyone, regardless of your background, your profession, your income level.
Right. We all have brains, and sometimes those brains need a little extra support, and that's okay.
Absolutely. Speaking of conditions that are often misunderstood, there's schizophrenia. It feels like there are a lot of misconceptions surrounding that one.
There are a lot of misconceptions about schizophrenia. It's one of those conditions that's often portrayed inaccurately in movies and TV shows.
Right, like you see someone talking to themselves, and people are quick to say, oh, they must be schizophrenic.
Exactly. And that's just not accurate or fair. Schizophrenia is a chronic, serious mental disorder that affects a person's ability to think, feel, and behave clearly.
So how would you describe it? What's actually happening in the brain with schizophrenia?
It's complex, but one of the hallmarks of schizophrenia is something called psychosis.
Psychosis, what does that mean?
Psychosis is basically a disconnect from reality.
A disconnect from reality.
Right. So someone experiencing psychosis might hear voices that aren't really there, see things that others don't, or hold really strong beliefs that aren't based in reality, which are called delusions.
Oh, wow. That sounds really scary and disorienting.
It can be incredibly disorienting and frightening for the person experiencing it, and those are considered positive symptoms.
Positive symptoms. So those are things that are aid to the person's experience.
Exactly. They're experiencing things that others don't, and then you have negative symptoms.
Yeah.
And these are things that are taken away from the person's experience.
So like what kinds of things?
We're talking about things like social withdrawal, apathy, lack of motivation, flat affect, things like that. And sadly, these negative symptoms can be some of the most debilitating and make it really hard for someone with schizophrenia to, function in their everyday life.
I can only imagine. It sounds incredibly challenging. And it's not just about medication, right? To treat it, it's got to be more than that.
You're absolutely right. Medication can be really helpful in managing those positive symptoms like the hallucinations and delusions, but it's not a cure-all. And medications often come with their own set of side effects.
Which can sometimes be just as bad as the symptoms themselves.
Exactly. So it's really important to find a balance. And that's where things like therapy, support groups, those are absolutely crucial. They help people develop coping mechanisms, build a support network.
Right, because it's not just about managing symptoms. It's about improving someone's overall quality of life.
100%. And on that note, I think we've given our listeners a lot to digest today.
We have covered a lot of ground. It's been fascinating, though.
It always is when we delve into these topics. The brain is just endlessly fascinating.
It really is.
Yeah.
It's made me appreciate just how incredible and complex our brains and bodies are.
And how much we still don't know. But hey, that's what makes this journey of discovery so exciting, right?
Absolutely.
Yeah.
There's always more to learn. To all our listeners out there, if any of the topics we discussed today resonated with you, please remember that you're not alone. And don't hesitate to reach out to a healthcare professional if you have any concerns.
Well said.
Until next time, keep those brains curious, everyone.